Hello once more, it's Sean once again. This time we're going to have a look at a paper 3 from AQA's Practice Set 2 series of papers. So this one is a paper with a scientific calculator which can be used, so definitely do use it, and if you've not got a scientific calculator yet, get one now. Okay, so let's have a look at the first question. Question 1. Circle the percentage that is greater than 3/4 and less than 4/5. So what we can do here is find out what 3/4 and what 4/5 is as a percentage and find out which one of those is between them. So to change from a fraction to a percentage, we can do that by just multiplying the fraction value by 100. So 3/4, if we multiply that by 100, because a percentage means out of 100, we get 75%. It's handy to know just off the top of your head really that 3/4 is 75%, but if you're not sure, this is how you can check on a calculator. And 4/5, in the same way, we can check. And 4/5 comes to 80%. And so what this question's asking is, which one of these is between 75 and 80? Well, 75% isn't greater than 3/4 because it is 3/4 exactly. 80% isn't less than 4/5 because 80% is 4/5 exactly. The only one between these two is 78%, and so that's the one we need to circle. Part B, we can use a similar idea to what we used for Part A. This time we're just circling the fraction that's greater than 0.3 and less than 0.4. Like before I mentioned, you can change fractions to percentages by multiplying by 100. Well, the same works with decimals as well. If we multiply the decimal by 100, we can change it to a percentage. And so 0.3 as a percentage, we can just take the decimal, multiply by 100, and that gives us 30%. In the same way, 0.4 would give us 40%. There's several ways you can do this. This is just one way I'm mentioning here. So 1/4, we can also multiply these fractions now by 100. So we can just compare them all as percentages. So 1/4 multiplied by 100 is 25%. 1/3 as percentage, what you'd get is 33.3 recurring. So 1/3, whoops, multiplied by 100, 33.3 recurring percent. So about 33% to the nearest percentage point. That dot just means it's 33, then 0.3 going on forever. 3/10 in the same way, you'd find that would be 30%, and a half as a percentage you'd find would be 50%. So we want to circle the fraction which is between 30 and 40%. 30% isn't between, it's exactly 30%. 50 is too big, 25% is too small. The only fraction which is between 0.3 and 0.4, therefore, is 1/3. Question 2, we need to circle which statement's true. 4 different statements. So what I've done here is I've decided to just draw in a number line to try and show you how a number line works. So if we have a look at this number line, 0 divides positive numbers from negative numbers. And so the bigger the positive number, the greater the number. In the same way, the smaller the number is, the greater it is on the negative side. And so down here it'd be -11, -12, -1 million. The bigger numbers would be going towards positive 1 million. So I've just highlighted each number according to this line here. So is -6 greater than -2? That would have to be where -6 is on the bigger side of a number line. But as we can see here, -6 is on the smaller end of a number line relative to -2. And so it's not the first statement that's true. Definitely not. This one over here, minus 6 is greater than 2. Well again, minus 6 is here, 2 is on the bigger side, so 2 is bigger than minus 6, so it's definitely not that one. Here it says is minus 2 greater than 6. Again, compare minus 2 and 6, and minus 2 is on the smaller end of 6. Or you can think of it as 6 is on the bigger side of minus 2, so it's not this one. But over here, minus 2 is greater than minus 6. Well, this time, minus 2 is on the right-hand side of minus 6, unlike the other ones. And so for that reason, this is one which is true. So we need to circle that minus 2 is greater than minus 6. Question 3. Y is a whole number. Circle all the words that describe 5y. So 5y simply means 5 multiplied by y. And so, as long as y is a whole number, y could be anything. So if y was 1, for example, 5y could be 5 times 1, which should be 5. That's an odd number. One whole number more than 1 is 2. So 5y could also equally be 5 times 2, which is 10. And 10 is an even number because we can half it with no remainder. And so as you can see, it could be odd or even. So we need to circle the final option. Question 4, we have a bank statement. I'm just going to mention here what credit and debit mean. So to put it simply, credit just means money into an account. So credit in this case is good. Credit is money going in. Debit, I always think of it as debit can't be spelt without using the word debt. Debt is bad, as is money going out of an account. So credit is what goes in, debit is what goes out. So as long as you remember those two definitions, it'll make doing this question much more straightforward. Balance, by the way, just means the amount in the account right now. And so on the 13th of October, the starting balance was 136.05. Cash is paid in, it then goes to 176.05. Now a credit of £65.20 goes in. And so this line here will be £176.05 like it was before. But because credit means money in, I'm going to add on an extra £65.20. And doing that, we get £241.25. Now the next two transactions are debits, money which goes out of the account. And so we need to be taking away these amounts from the previous one. And so what happens next is £83.19 leaves the account. So we need to subtract £83.19, which is £158.06. Then we take out another £164.76 to pay this water bill. So then minus 164.76, and we get minus £6.70. That means £6.70 overdrawn. But then a wage goes in next day, which is for £46, and so we then add in £46 to the balance, which brings the balance back out of overdraft to £39.30. And so that's all the balance column completed, and so that's 3 marks. Take away 1 mark for each mistake you make. Hopefully you won't make any, but those are the figures needed to get full marks. Here are some cards, 4 different cards. We need to choose a card so that the answer is as small as possible. So we need to work out the answer. Now, this is a calculator paper, so as long as you're careful and comfortable using your calculator, you should find this quite straightforward. It's basically, you can try all these numbers here, plus 8.3, plus 8.9, plus minus 8.9, or plus minus 8.3. you should find that the smallest it can be is when the card you choose is minus 8.9. If we add a negative number, if the two signs next to each other are different and opposite, a plus and a minus, or a minus and a plus, mixed makes minus. So this is the same as minus 3.5 subtract 8.9. And so understandably, the answer will be as small as possible when you subtract the biggest possible thing from it. So the biggest thing we can take away is 8.9. And so then another mark for working out what this answer would be. So if we type in the sum exactly as it appears, we should find that it comes to minus 12.4. Part B, now we need to work out, again, whichever card to use so the answer is as small as possible. This time we're already subtracting. If we pick a minus number here, if the two signs next to each other are the same, it makes it a positive thing. If you minus a minus, it's the same as adding on a number. So it's no good picking a negative. What we need to be doing is subtracting the greatest number possible. The biggest number here is 8.9. So that's the card we need to pick. So if we pick that card and work out the calculation, again that'll come to minus 12.4. And that's question 5 done. Question 6. We have a fair spinner and it's got 6 equal sections. The arrow on the spinner's spun and we need to complete each of the following sentences with the correct probability. So first of all we need to decide the probability that the arrow will land on a factor of 8. So we can think of the factors of 8 right now. Factors just mean what divides into a number. So the smallest number we can divide 8 by, or we can divide any number by, is 1. 8 divided by 1 would be 8. We can also divide 8 by 2, which would be 4. And so the factors of 8 we can see here are 1, 2, 4 and 8. So there's 4 factors of 8, and all 4 of these factors appear once on this spinner. And so because 4 sections are a factor of 8, we can say that's 4 out of a total of 6 are a factor of 8. The next thing we need to think about is the probability it will land on a prime number. Well, prime numbers begin with the number 2. A prime number can only be divided by 2 different things. So 1 isn't prime because 1 can only be divided by one thing, 1. A prime number has to have exactly 2 factors. And so the first one's 2, the second one is 3, 5, 7, 9 isn't, then we have 11, and we keep going up. But as you can see, no numbers here are as big as 11, so we don't need to go that high. And so, if we have a look here, a prime number, we've got 2, and we've also got 5. And so there's only 2 sections out of 6 on here that have a prime number. If you want to simplify down these answers, by the way, you can do. You can call that 2/3, and you could say the final section here is 1/3. But for probability, we don't need to worry in the same way about simplifying down fractions as we usually would. And so that will do for answers for both of these sections. Part B of question 6. We've got a different spinner with 5 sections, and we have to decide on numbers for each section so that the probability that the arrow lands on a 3 is 2/5. The range of the numbers is a 3, and the sum of them all is 21. And so if you notice here, there's 5 sections, and so if the probability that the arrow lands on a 3 is 2 out of 5, that must mean that 2 out of these 5 sections have to be a 3. And so the first thing we can fill in is just to put 2 3s on 2 of the sections. From that, we can now think of the other 2 points. So the range of the numbers is 3. And so the biggest possible number we could have is going to be a 6. If we had a number bigger than a 6, for example 7, the range is the biggest subtract the smallest. So if one of the numbers was a 7, the range would have to be at least 7 subtract 3, which would be 4. And so we can't have a number bigger than 6. And so we need to think of the other 3 numbers here. So it can't be bigger than 6. None of these 3 numbers can be bigger than 6. And because the sum of all the numbers is 21, we can now work out how much these other 3 numbers need to add up to. If all of the numbers come to 21, and we've got 2 3s already, then these other 3 numbers must add up to 21, take away 3, take away 3, which is 15. So we need to think of 3 numbers that add up to 15, but we can't have one or any of them bigger than 6. So maybe you could have 6 and 6. 6 plus 6 is 12. So for it to add up to 15, the other number would be 3, which is a tempting answer, but if we had that one as a 3, we'd have 3 3s, which wouldn't be a probability of 2/5. Only 2 of the sections can be a 3, and so 6, 6 and 3 doesn't work. And so what we could do, using a process of trial and error, is we could try one number smaller than a 6, which is 5. 6 plus 5 is 11, so we could have another number which is a 4. 6 plus 5 plus 4 is 15, and so if we had 6, 5 and 4, that would meet all of these criteria. The probability of landing on a 3 would be 2/5. The range of these numbers would be 6 minus 3, which is 3. If you add up all these numbers to double check, you'd find that the sum comes to 21. And so that works for question 6b. 2 3s, a 4, a 5 and a 6. Question 7 is about junctions on a motorway. We're told that the distance from junction 2 to junction 3 is 8.7 miles. So from junction 2 to junction 3 is this section of the motorway here, which, as it says, is 8.7 miles. So it says the distance from junction 1 to junction 2 is 1/3 of the distance from junction 2 to junction 3. And so if that's true, 1/3 of the distance from junction 2 to junction 3, that just means 1/3 of 8.7. Because the distance from junction 2 to junction 3 is 8.7. And so we can work out 1/3 of 8.7. To work out a third of a number, we just divide it by 3. So we can do 8.7 divided by 3 on the calculator, or if you prefer, you can use a fraction button and just type in 1/3 multiplied by 8.7. Either way you do it, you should get 2.9. And that is the distance from junction 1 to junction 2. 1/3 of 8.7, which is 2.9. So that doesn't say, we just worked out, that's 2.9. So the question here is asking the distance from junction 1 to junction 3. So that's the complete distance all the way from one end to the other. So that's 2.9, which we just worked out, plus 8.7. So if we just work that out on our calculator, 2.9 plus 8.7, you should find that it comes to 11.6. So the total distance from junction 1 to junction 3 is 11.6 miles. Question 8. We've got a coordinate grid. A, B, C are 3 vertices. Vertices is just a fancy word for corners. Corners of a quadrilateral. Again, that's just a fancy word for a 4-sided shape plotted on a centimetre grid. It says plot D, so for A, B, C, D is a rectangle. You should well know that for a rectangle, what you've got is 2 sides which are equal and opposite and parallel. So the top of a rectangle, is parallel to the bottom of it. So if you have a look here from B to C, that line goes in this direction and is that long. And so we can use that to our advantage. With a ruler, keeping it in the same direction, if we just stick an extra line above BC, that tells us that the top must be going in this direction. In the same way, if we do a second line from B to A, we know that the opposite side of the rectangle will be the same length and going in the same direction. And so if we just take the same length line, going in the same direction, and pop it here, then we will have made the rectangle. And so point D, remember we need to label point D, will be this point here. So it needs plotting and labelling D so that we can answer the question. So that's where point D needs to go. The next question, part B, it says E is the midpoint of BC. BC is just the line all the way from B to C. And so the midpoint, halfway along, would be this point here. And it says circle 2 answers that describe the triangle ABE. So if this is E, then ABE will be the triangle which connects all of these points together. Like this. And so ABE, I'll just colour it in just because it's an excuse to colour in. And being a maths teacher, I don't really have much time to colour in now, so if I can get a chance to colour in, I will do. All my time seems to be spent doing equations and solving problems and marking, so I'm talking rubbish, as you can probably guess. Anyway, I'm just colouring in ABE, just to make it clearer. And if we have a look here at this one, you can hopefully see that this length here, this blue line, which is 1 square along, 3 squares up, is the same length as BE, because that's 1 square down, 3 squares along. And to be honest, you can always check this on a calculator. You can always check this on a ruler by just measuring. Now your measurements may be different to mine, because my diagram may well be to a different scale after I've enlarged it, but what you should find is if you put your ruler on BE, in my case it measures 3, which isn't entirely accurate, but whatever distance you measure from B to E, you should find it's exactly the same from A to B. In my case it looks like 3 centimetres each. As I say, your distance will be different, but whatever your distance is, from B to E, it will be the same as from B to A. And so, based on that, if we've got a triangle with 2 sides that are equal, by the way, if you measure this one, it wouldn't be the same, you'd find that it must be an isosceles triangle. An isosceles triangle means only 2 sides are equal. Not 3 sides, because that would be equilateral, but 2 sides only. Now, the second property, it can't be scalene, it can't be equilateral. A triangle can't be equilateral and isosceles, so it's got to be right-angled. But again, if you want to double check, you should be prepared for your exam, and you should have one of these with you. So if you have one of these, if you measure the angle at B, you'll find that comes to 90 degrees. So I'm just going to try and move this over here. Here we go. I thought I was going to get stuck then. So if we start at 90 degrees, so we start at 0 and measure from one end to the other line, you can see there that it's 90 degrees in between this one and that one. And so for that reason, this is a 90-degree angle, which makes the triangle a right angle. And so not only is it isosceles, it's also a right-angled triangle. So we can also circle right-angled. Part C, we have to circle the ratio of the area of triangle ABE to the area of the entire rectangle ABCD. And so what we're going to do here is just to try and divide this rectangle up into equal parts, like so. What you can hopefully see and picture is that this triangle represents only one section coloured in out of a total of 4 different sections of a complete rectangle. That's one piece, and there's 4 equally sized pieces within the rectangle. 1, 2, 3, 4. And so the triangle is just only one out of 4 of such sections. And so the ratio of a triangle to the area of a rectangle will be 1.4, because the area of a rectangle is 4 times bigger than the area of the triangle. And so for this question, we circle 1.4. And that's question 8 completed. Question 9. In a class, the number of girls as a fraction of the number of boys is 5/4. Part A is a 1-mark question as well, bear in mind. Write down the number of boys as a fraction of the number of girls. So with fractions, the language of fractions links often very strongly to the fraction itself. What I mean by that is, with the English, with the wording of a question with fractions, whatever comes after the word of will always be the number that goes on the bottom. In this case, it's the number of boys, and so that means 4, the bottom number of a fraction, will relate to the boys. Whatever comes before the word of, in this case it's the number of girls, will mean what number is on the top of the fraction, which is 5. The most natural way I can probably explain this would be, for example, if you were to do some homework at school and you got 7 out of 10. If you got 7 out of 10, you probably know that would be written as 7 out of 10. The same rule applies, because whatever comes after the of, in this case a 10, goes in the bottom of a fraction, and the 7, which is mentioned first, goes at the top. It's just something you don't really think about, but it's worth just spotting that pattern because it can help, for example, with questions like this. Part A, all it's saying is it's reversing the order. So now it's saying the number of boys as a fraction of the number of girls. So now because the order's reversed, the order of the numbers in the fraction will be reversed as well. So because boys are now mentioned first, boys will now go on the top of the fraction. Oops, wrong colour. Boys as a fraction of the number of girls. So because the order of the things is reversed in the question, the order of the numbers is reversed in the fraction. Part B, again it says there's 20 girls in the class, work out the number of boys. And so if we just go back to part A for a second, the number of boys as a fraction of the number of girls is 4/5. And so because of that, we can use that fraction to work out the number of boys there'll be. And so if there's 20 girls, the number of boys will be 4/5 of 20, which we can do on a calculator without too much difficulty. We type in the fraction first and multiply by the quantity we're talking about. In this case, 4/5 of 20, which gives us 16. And so the number of boys in the class must have been 16. Question 10. Somebody's thinking of a number, and we're given instructions in terms of what happens to this number. And so a suggested method, I would say, would be to start with n, which is the number, and just take it in step by step what happens to the number each time. So we start with the number n. The first thing is 5 is added to the number. And so n comes along, the first thing that happens to it is we add 5. The second thing is it gets divided by 4. So after adding 5, we're going to divide that by 4. And the final answer that comes out after all that is 3.625. So what we can do now is reverse every single step, starting at the end, going the opposite way, and doing the opposite process each time. So starting with 3.625, we can work backwards to work out what n must have been at the very beginning. So going backwards, instead of dividing by 4, going the opposite way, we'll do the opposite thing. Opposite of dividing by 4 would be to multiply by 4. So 3.625 multiplied by 4. What I'd suggest you do is to write down the intermediate steps along the way. So 3.625 multiplied by 4 would give us 14.5. So after multiplying by 4, we'd have 14.5. Then instead of adding 5, what we're going to do next is the opposite of adding 5, which is to subtract 5. And so 14.5 subtracted by 5 will tell us what n was at the very beginning. So if we subtract 5 from this, we would get 9.5. And so the number this person was thinking about must have been 9.5. Then says work out my final answer if I add 4 to my number. So if I add 4 to n, (9.5) plus 4 will be 13.5. And then if we divide that by 5, that will tell us what the final answer would be. So 9.5 plus 4 is 13.5, like I said. And then divide that by 5, we'd get 2.7. So the final answer must be 2.7. Just following the steps as we're told. So we end up with n, which is 9.5. We're told to add 4 to it, which we did. After we add 4, divide by 5. The final answer we get from all of that is 2.7. So that's question 10 completed. Question 11. The scale on a map is 1 to 200,000. And we have to work out how many kilometers is represented by 2.5 centimeters on a map. So I'm just going to write out the scale factor here. It's 1 dot dot 200,000. So what this means is that for every 1 centimetre or any unit at all on the map, it represents 200,000 times of that distance in real life. Now, if ever we have a ratio where one number is 1 and the other number isn't 1, if it be a ratio or a conversion factor or anything, if it's in this form where one number is 1, the other number isn't 1, we can change from one to the other by either multiplying or dividing by the number that isn't 1. And so in this case, we either multiply or divide by the 200,000. So the small number for 1 will represent the small thing. Which is bigger, a map of something or the actual place itself? Obviously the map's going to be the smaller thing. So the map is represented by the 1, the 200,000 is real life. So to change from the map distance to the real life distance, we're going from a small number to a big number, and so to do that we'll be multiplying by 200,000. Going the other way around, from the real life distance to the distance on the map, that would be dividing by 200,000. So in this case, the distance on the map is 2.5 centimetres. So we can convert that to the distance it represents in real life by multiplying by 200,000. So 2.5 multiplied by 200,000 comes to 500,000. Centimetres in, so centimetres will come out. 500,000 centimetres. Now we want the answer to be in kilometres. Not in centimetres, but in kilometres. So what we need to do is change, first of all, I'd say, from centimetres to metres. So we need to remember that 1 metre is 100 centimetres. Again, this is a relation in the same form, where one number is a 1, the other number isn't 1. So to change from metres to centimetres, from the small number to a big number, we'd multiply by the number that isn't 1, in this case for 100. Or to change from centimetres back to metres, we'd have to divide by 100. So in this case, we've got an answer in centimetres. We want to change to metres. So from centimetres to metres, we'd have to divide by 100. So 500,000 divided by 100 is 5,000 metres. And then from metres to kilometres, we need to know that there's 1,000 metres in every kilometre. So in the same way, to change from metres to kilometres, 1 kilometre, just get rid of all this, 1 kilometre is 1,000 metres. Again, it's a ratio in the same form. One number's a 1, other number isn't 1. So to change from kilometres to metres, from small number to big number, would be multiplying by 1,000. To go the other way around, from a big number to a small number, we'd have to divide by 1,000. And so in this case now, we want to change from metres to kilometres, and so we'd have to divide by 1,000. So finally, 5,000 metres divided by 1,000 would give us our final answer of 5 kilometres. So that's the distance it represents on the map. 2.5 centimetres would represent 5 kilometres. Question 12, we have some numbers of a sequence. We've got 23, minus 14, and 9. So each term is found by adding the previous two terms together. We need to work out the next two terms. And so what we need to do is add up the previous two to get the next one. And so the next term, this one here, we could get by adding minus 14 and 9 together, which would be minus 5. So the next term is minus 5. The term after that, we'd get from adding 9 and minus 5 together. And so 9 added to minus 5 would be 4. So the next two terms are minus 5 and 4. Now, part B, it's the same sequence, just to remind us that it was minus 5 and 4. The sequence continues, it says, and it says how many negative terms are in the sequence. So let's just carry this sequence on a bit further. So the next one we'd get from adding the two before it together. So this number here would be minus 5 added to 4. Which is minus 1. This one here would be minus 1 plus 4. Which would be 3. And this next one would be minus 1 added to 3. Which is 2. And so the number of negative numbers we've got, negative terms, we've got minus 14, we had minus 5, and minus 1. And that's only how many there will ever be. So there will only be 3 negative terms. Now, to explain that, we've got 3 and then 2 after. Now, this sequence is found by adding together the previous two numbers. And so now, because the previous two numbers are positive, if you add together two positive numbers, the answer is always going to be positive from now on. And so we can say that the next two terms after minus 1 are positive. So all the terms after them must also be positive. Just words to those effects. You don't have to word it in exactly the same way as me, but something along those lines. After minus 1, that's the last negative number, so there'll be no more after that. Question 13, we've got a table of values here, and a graph's been drawn by Guy. And so we need to find and write down 3 different mistakes he's made. So, in any order, if you have a look at this point here, 0 and 1, then 5 and 6, and then 10 and 11. Let's see where all these points are. This coordinate here means when x is 10, y is 11, which is up here. That's in the right place. 5 and 6, x is 5, y is 6 would be here. Again, that's in the right place. But 0 and 1 should be here. And so some people might say the line's bent or the line isn't straight. That's not untrue, but the reason is because 0 and 1 has been misplotted. So this point here should have been there. And if that were the case, the line would be straight. The line should be something like this. But as you can see, it's clearly not. So another thing to say is that if you have a look at the axes, the 3 has been repeated on the x-axis. So we can write that down as well. Number 3 is repeated on the x-axis. And finally, if you have a look at the axes themselves, they've not been labelled. That should be labelled x. This should be labelled y. So the third mistake that he's made is the axes have not been labelled. Question 14. We have a diagram showing a quarter circle with radius 6.5 centimetres. So we have to work out the area of the quarter circle. So you've had fair warning that it's not a full circle. It's mentioned twice that it's a quarter of a circle. And so just to try and make that a bit clearer, not that it should need to be, I've just drawn in the full circle around it. So hopefully you can see that this quarter circle is just one piece out of the 4 bits, out of the 4 quarters of a circle, which you'd have for a full circle. And so the only bit we're interested in really is this quarter we've been shown. So what we'll need to do is remember the formulae for circles. So a rather silly way I remember it, because I like to eat, is that chicken pies are delicious, and also that apple pies are too. So C stands for circumference. The circumference of a circle is pi multiplied by the diameter. A stands for area and apple, and that's pi multiplied by the radius squared. So because we're interested in the area, we're going to be interested in using this formula here. And so this is the one we're interested in. And so the area of the full circle is pi multiplied by the radius squared. So the radius, we've been told, is 6.5. And so the area of a full circle is pi multiplied by 6.5 squared, which we can type into our calculator. Now there is a fraction button on calculators. Beg your pardon, there's a pi button. So for example on this one here, the pi button sits just above the x10x button. So we press shift, this button here, we get pi, where we can multiply that by 6.5 squared, which is 132.7322896. Don't round off yet, only round off a calculation when you write at the end of it. If you round off at the middle bit, you'll get some rounding error, so never round off until the very end step. So 7322896. But we did say it's a quarter of a circle we're interested in, not the whole thing. This is the formula for the area of a whole circle. So for the quarter circle, we're just going to take this value here, and to find a quarter of something, we divide it by 4. So if you take that figure and divide it by 4, the calculator may give you an answer in terms of pi, but as a numerical value, we would get 33.1830724. At this stage, you would be allowed to round it to something sensible. If you're not sure how much to round it to, just give the full answer on your calculator if you're not sure, or if a question doesn't tell you and you're not sure. But what I'd say here would be sensible would be to 3 significant figures, or to 1 decimal place. So that'd be 33.2, because next to the 1 is an 8. So if you round this to 1 decimal place, which in this case is the same as 3 significant figures, that'd be 33.2. 33.2 centimeters squared. And that's the answer we can put down as the area for the quarter circle. Question 15. We've got £800 invested for 3 years at 2% simple interest per year. And we have to work out the total interest. Simple interest just means the interest does not alter from year to year. Unless it were a particularly horrible question where something's been withdrawn from the bank account during that time, but I've never seen that. That would be particularly horrid. So simple interest just means the interest doesn't alter from year to year. So to do this question, we just need to work out the interest for 1 year first. So for 1 year, the interest is 2%, which means 2 out of 100. 2% of £800. Remember, percentage means, by its definition, a fraction out of 100. And we work out that percentage of the initial figure, which in this case is 800. And so 2% of 800. Let's just do this now, and let's see what it comes to. We get £16. So because we want the total interest for 3 years, we just take the interest for 1 year and multiply it by 3. So the interest will be about £16 multiplied by 3, which you should find is £48. And so for 3 years, the interest in total comes to £48. And that's our final answer for the total interest. It doesn't say the total amount in the account, it just says the total interest. Just pay attention. If a question asks for total interest, it's just how much has been added on to the account. If a question had have asked work out the total amount in the account, that would have been 800 plus 48, which is £848. But in this particular question, the final answer is just £48. Question 16 is a bit of a tricky one, really. We've got this shape, which is made using 3 identical rectangles. We need to work out the area of the shape. And so, one thing we could work out, for an area of a rectangle, we need the length and the width. And we don't know yet the length of each one of these little rectangles here. What we can do, though, is notice that we've actually got 3 rectangles from end to end across the entire length of the shape. So if I just do the lengths like this, and the widths I'm going to do with a red line. So if I just take one of these rectangles here, which I've managed to draw in over here. So I'm just going to pinch this, put it over here. So for just one of these rectangles, if we just think of a length for this one. As mentioned here, 3 rectangles from end to end must be the same as 16.2. And so just thinking about the length of each tiny rectangle, we know that 3 lots of the length, 1, 2, 3, must be the same as 16.2. We can then work out what each individual length of the rectangle is by rearranging this equation and dividing 16.2 by 3. Swap side, swap sign. Opposite of multiply is divide. And so the length of each little rectangle is 16.2 divided by 3. So 16.2 divide by 3, 5.4. So the length of each one is 5.4 centimetres. And so we're up and running. We've not completed the question by any means, but that would be a mark at the very least. So 5.4 centimetres. So we know the length. The other thing we need to work out for a rectangle is the width. So I'm going to show you a couple of different ways of how you can think about this one. The first way is an algebra-based way. The second way might be slightly easier. So if we have a look at the total length of this rectangle here, we can think of that total length, not W, sorry, as being length of a small one plus length of another small one plus length of the other small one. But if you look here, from end to end, you can also think of that as being the width plus 1 length. This is the width of a rectangle. That's the length. And that's the width. And so if we look at the whole length, which is 16.2, in this form, it's got to be the same as if you think of it like this. And so what I'm saying here, if we look at these two, is that the top row, W, the width plus the length, plus the width plus the length, plus the width, is the same as 3 lengths altogether. Now this left-hand side we can neaten up slightly. So we can group together how many W's we've got. 1, 2, 3. We've got 3 W's. And 2 lengths. That equals 3 lengths. And so we can rearrange this now. Or what we could do is substitute in the numerical answer for what the length is, which we already know is 5.4. That's just one option. But anyway, if we take away these 2 L's and put them to the other side, if we swap the side, we swap the sign. Opposite of plus is subtract. So I'm just going to give some more space. So that tells us that 3 W's must equal 3L take away 2L, which is just 1L. But we know what L is. The length is 5.4. And so that tells us that the width, we can work out that 3 is multiplying the W. The opposite of multiplying is dividing. So if we swap side and swap side, the width will be 5.4 divided by 3. Essentially the width is just 1/3 of the length of each rectangle. So 5.4 divided by 3 is 1.8. So the width of each rectangle must be 1.8. Now I did say I'd give you another way of thinking about this. What you might have noticed, looking at these diagrams here, is that 3 widths must be the same as a length, because here we've got 3 lengths in a row, which is the same as 2 lengths and 3 widths together. So if you were to think of it like this, if I just grab one of these, that's for length, and each one of these widths, if I put one here, another one here, another one here, it's not quite a perfect diagram, I know, but you should hopefully see using this way that 3 lots of a width is the same as the length, and so you can get the width by dividing the length into thirds. So 5.4 divided by 3 is 1.8. So for each little rectangle, the area of one, I'm going to call it little, because everything's relative, it might not be little compared to its baby brothers. The area of one little rectangle, or the area of any rectangle, is the length multiplied by the width. And so in this case, it'll be 5.4 multiplied by 1.8. So 5.4 multiplied by 1.8 comes to 9.72 square centimetres. So because we've got 15 of those rectangles, the total area, it says here there's 15, total area for the big rectangle will be 15 multiplied by 9.72. So again, if we just use our calculator to work this one out, so 9.72, multiply this by 15, and we'll find that the area of the whole shape is 145.8 square centimetres. Quite a challenging question, that, to say the least, but the final answer you should hopefully arrive at is 145.8 square centimetres. Question 17, part A. We've got one which says factorise x squared minus y squared. The thing to notice here is that x is squared, and I'm subtracting another thing which is also squared. If you're not sure how to do these, and look at it's a 1-mark question, there's a very simple method for these, and it's a type of question called the difference of 2 squares. If you've not seen one of these types of questions before, I'd recommend either Googling or revising or looking through your notes, because once you know how to do them and once you spot them, the method's incredibly easy. But it's a case of just knowing if it's a difference of 2 squares question. All we do is we open up 2 brackets, and for positive square, we think what thing multiplied by itself gives us this. So x times x would give us x squared. And so we put an x in the first bracket and an x at the beginning of the second bracket. And whatever squared thing is a negative, we put that last in both brackets, because y multiplied by y is y squared. So it's effectively taking the square root of each thing, putting the positive square root first in each bracket, and one which is a minus, we put that square root at the end. But whatever's the negative square, we put a plus in front of it in one bracket, and a minus in front of it in the final bracket. And so factorised, that's all we do. X plus y, x minus y. That's fully factorised now. Part B, we need to solve 2x over 5 plus 1 equals 13. I'll show two different ways of doing this one. So the first method I'm going to use is the flowchart way of doing it. And we do this by starting with x and taking it step by step, asking what happens to x along the way. The first thing that happens to x is it bumps into the 2. The 2 is multiplying the x. Two things next to each other in algebra means one thing multiplied by the other. And so x is being multiplied by 2. After we multiply it by 2, we divide by 5. After being divided by 5, we add 1. And nothing else happens on the left-hand side. And so all that must equal 13. Then what we do is we're going to work from the opposite end, going back on ourselves, doing the opposite thing at each stage. So starting at 13, we're going to reverse every single step as we go the opposite way. So above we added 1. The opposite of adding 1 is to subtract 1. Now after each step it's always a good idea to just write in what x is along the way. So 13 take away 1, so far I've got 12. The next step, before we were dividing by 5, the opposite of dividing by 5 is to multiply by 5. And so 12 multiplied by 5, right now we'd have 60. And the final step, instead of multiplying by 2, we're going the opposite way, so we'll do the opposite, which is dividing by 2. And so 60 divided by 2 gives us 30. And so x equals 30. The second way I'm going to show you is the whole idea of swapping side and swapping sign. And so we've got 2x plus 1 equals 13. So what we can do is we aim to have x on its own. So right now we could get rid of this plus 1 by taking it to the other side. But if we swap the side of the equation, we swap the sign. Opposite of plus is subtract. So now we'll just have 2x over 5 on this side of the equation. On the right hand side we'll have 13 minus this 1, which will be 12. That 5 is dividing everything above it. That 5 is dividing the 2x. And so if we move this 5, which is currently dividing, and swap the side, we'll change it from dividing to the opposite, which is multiplying. 12 multiplied by 5 is 60. So now we'd have 2x equals 60. We want to have just one x on its own. So how can we get rid of that 2? We can ask what's the 2 doing to the x. The 2 is multiplying the x. Opposite of multiplying by 2 is divide by 2, because whenever we swap the side, we swap the sign. 60 divided by 2 would be 30. And so different method but same result, x equals 30. Question 18, we have a parallelogram A, B, C, D. It says P is a point on BC. Write down the size of angle X. You must show all your working, which may be on the diagram. There's 3 ways I can think of to do this question. I'm going to show you just 2 ways. And so one thing we could do is we could use the angle facts of a parallelogram. So one angle fact of any parallelogram is that the opposite angles of a parallelogram are always equal. So we can use that fact to help us. And so opposite this angle here, opposite this corner, is this corner here. And so if this one at B is 130 degrees, the opposite corner to B is D, and so the corner at D will also be 130 degrees. I'll just do a little arrow pointing to it like that. That's 130 degrees. Now, angles inside a triangle add up to 180 degrees. And so we can work out this of angle of a triangle APD. And so if this is 35 and this one's 100, the angle here at D we can work out by doing 180 subtract 100 subtract 35, which is 45. And so the angle here at D will be 45. So if a whole angle at D is 130, but this bit here is 45, we can calculate x by working out the difference between these two angles. So angle x will be the whole 130 subtracted from 45. And if we try that on our calculator, we should find that x is 85 degrees. I'm now going to show you a second method which doesn't rely on you remembering any angle facts of parallelograms. So using this other method now, we're now going to work it out by not thinking about that at all. So what we need to do now though is to at least remember angle facts involving parallel lines. And so I want to have a look at first of all is this top line from B to P all the way across to C and beyond. This straight line here. Now the angle at B is 130. Now that angle here will be the same as this angle here. Now this is called a corresponding angle. So we can say that's 130 degrees because corresponding angles are equal. Corresponding angles always look like F angles, so the corners of the F will always be of equal size. So that's 130 because this one here is 130. Then we can use the angle fact that angles on a straight line add up to 180 degrees. If this bit's 130, this bit here will be 180 take away 130, which will be 50 degrees. The next thing to spot, after realising that's 50 degrees, is we can work out this angle here eventually. Work out this angle of the triangle. But to do that, we could do also working out this angle here. Now, just like we used corresponding angles earlier, we can use another angle fact to work out this one over here. So this angle here will be the same as 35 degrees. And the reason for that is because alternate angles are equal. And so if I was to just draw in a Z angle, what it means is the corners of the Z are of equal size. And so if this one's 35 degrees, the angle at P must also be 35 degrees. So we can say that the angle BPA is 35 degrees because alternate angles are equal. And now, if this is 35, and that's 100, we can make out this one here, CPD, because these three angles are joined together at a point on the same side of a straight line. And angles on a straight line will add up to 180 degrees. And so this angle here we can calculate by doing 180, subtract 100, subtract 35, which will give us 45 degrees. And so now just looking at the triangle PCD, we've got 45 degrees, we know this one's 50. And so because angles inside a triangle also add up to 180 degrees, x must be 180 minus 45 minus 50, which will give us 85 degrees. And so again, x would be 85 degrees. Part B, we need to work out the size of angle y. And so the easiest way I'd say to work out angle y, would be to work out that these two angles here are corresponding angles, just like we did earlier. And so this angle will be the same as the angle at P. So that's 35, because that one's 35. Alternate angles are equal. And because of that, we now know 2 out of 3 angles in this top left triangle. And so y will be 180 minus 130 minus 35. Which is 15. And so y equals 15 degrees. Question 19. Paul won a race with a time of 71.3 seconds. So that time has been rounded to the nearest tenth of a second. So it's been rounded to that figure here. That's tenths. So nearest tenth of a second, it's 71.3. Now, error intervals often follow a particular pattern. So what it means is, what's the smallest possible value t could have been before it was rounded? And what's the absolute limit of t, which it can't be more than? So what's the smallest thing it could be, and still round to 71.3? Well, the absolute lower limit of rounding up is if something is 5 or more. And so for this 2 to have rounded up to the 3 that it becomes, the smallest number next to it was a 5. Any smaller than a 5, if this is 4, it would have stayed at 71.2 after rounding. And so it must be at least 71.25. Any smaller, it wouldn't have rounded up. Now, the absolute limit of what t could be would be 71.3 something. 71.34 would be fine. 71.35 is the absolute limit. In fact, it can't really be 71.35, because if it were 71.35, it would have rounded up to 71.4. But because this inequality symbol means strictly less than, we can say safely that the absolute limit of t would be 71.35. Now, the general rule for error intervals is that they'll end in a 5. In this case, which will normally be the case, but not always, I hate to say that a rule will always be true, but almost always for error intervals. The upper bound, the upper limit, will be the number it's been rounded to, with a 5 stuck on the end. The lower limit will be almost exactly the same number, but the number before the 5 will be 1 lower. So you get 71.35 and 71.25. So that's a little tip which I can give you, but just be careful when applying it. Always think of a question and make sure your answer makes sense. Question 20, we've got two right-angled triangles which are similar. And what we need to do here, first of all, is to write down the value of tan x. So tan x means trigonometry, so that's SOHCAHTOA. And so tan x is what T stands for. So T is tan of x, which means opposite divided by the adjacent. So in this case, O, which is the opposite side, we've been told is 3, because O just means side opposite to the angle. So opposite x is 3. And the adjacent side is 4. So the way I have to think about it is O is always opposite to the angle. The hypotenuse side H is always opposite the right angle, the longest, and the other side is just the A. And so O, opposite side is 3, the adjacent is 4. And so that's what tan of x equals. It's a slightly strange question. Usually with trigonometry we're asked to work out the angle, in which case it'd be tan minus 1. Or you're asked to work out the length of the side. Here we're just asked to work out what tan of x is. T stands for tan of x, so it's just opposite divided by the adjacent. If I had said work out the angle of x, it would have been different. Part B, work out the value of y. And so we've been told that these two triangles are similar, and so we need to find the two sides which relate. And so this side here, which is 3, corresponds to this side on the bigger triangle, which is y. And so we need to work out if one triangle is similar to the other, it means that one can be considered an enlargement of the other. And so if you have a look at this side at the bottom, it's gone from 4 to 6. So not a case of how many times, how many numbers we need to add on to get to 6. It's a case of how many times bigger, 6 is compared to 4. And we can do that by doing the biggest side divided by the smallest side, which is 1.5. And so that tells us that this big triangle here is 1.5 times bigger than the smaller triangle. And so what we do is you take 3, and we're going to multiply 3 again by the same scale factor, which is 1.5. And so 3 multiplied by 1.5 will tell us what y is, which is 4.5, because 3 multiplied by 1.5 is 4.5. Question 21. We're told a line has an equation of y equals 4x minus 5. We need to find the gradient of that line. Now, if a graph is in the form of y equals mx plus c, which this equation is, we know for definite, if a graph is in this form, that the number in front of the x, which is typically called m, represents the gradient. The gradient just means the steepness of the line. And the number at the end, which is often called c in textbooks, and by most teachers, including myself, is the y-intercept. So this question doesn't really involve much mathematical skill, it's just spotting the graph is in, the equation of the graph is in this form. So m, the number at the front of x, in this case, is 4. And c, the y-intercept, is -5. It's not 5 because that 5 is a minus. And so in terms of applying this to the question, the gradient is 4 because the number in front of the x, as I've said, is 4. And the y-intercept, the number at the end, is -5. Therefore, the y-intercept, that one is the one we circle. Question 22. At a nursery, the mean age of 4 children is 31 months. Now it's worth just reminding ourselves what the mean is. To calculate the mean, it's the total of all values. So in this case, the mean age will be the total of ages. So normally the mean is a total of values divided by the number of values. So in this case, number of values will be the number of children. So we can see which bits of this equation we know. So first of all, the mean of 4 children is 31 months. And so we're told first off that before anything happens, the mean age of 4 children is 31. And so the mean must be 31. And at first it's 4 children. And so the number of children, first of all, we can replace with 4. So the only thing missing is the total of all the ages. And so we just call the total something simple. In fact, we wouldn't really need to. This is an equation. We want to find out what the total of the ages is. So what's happening to the total of the ages is it's being divided by 4, which gives us 31. To get the total on its own, we can swap this 4 over, but for 4 swaps side, it swaps sign. Opposite of dividing by 4 is multiplying by 4. And so the total age of the 4 children is 31 multiplied by 4. (31 times 4 is 124 months. But then Katie joins, and so we do the same thing, but after Katie joins. Because Katie joining changes things. So again, using the formula for the mean, mean is the total of ages divided by number of children. So there was 4 children. With Katie coming along, that number of children is now 5. And so what we can do is plug in the numbers we know. For number of children, we can actually say is 5. So I'll put this number in. And the mean now is 30. And so in the same way that we worked out the total before, we can rearrange this new equation with Katie to find out the mean now. And so if we just move this 5 across, so we've got the total of the ages on its own, if we swap the side, we swap the sign. And so the total of ages now will be 130 multiplied by 5, which will be 150. So before Katie came along, the ages was 124 months. When Katie joined, the age increased to 150 months. And so we can work out Katie's age by doing the total of the final ages, 150, subtract 124. Katie coming along will have made the difference between these two. So 150 subtract 124 is 26. And so Katie must be, or must have been, 26 months. Question 23. John chooses a number at random from the digits 1 to 4. Matt does the same. Write down the probability that the sum of the two numbers chosen is a two-digit number. Well, the biggest number John could choose is 4. And also the biggest Matt could choose would be 4. 4 plus 4 equals 8. And so the maximum total is 8. So there's no chance that the sum can be a two-digit number. So the answer is 0, because it's impossible. Now, normally with probability spaces, or where you've got two events, you can do a probability space diagram like this, but you really would be wasting your time with a 1-mark question to do this. But what you'd find if you were to do this is that none of the totals would be a two-digit number. So the answer is 0, which represents impossible on the probability scale. Now 23b, we would benefit from doing a probability space diagram, because this time we're asked to work out the probability that the product of the two numbers chosen is a two-digit number. And so what we need to do here is a probability space diagram. So if we imagine John's possible numbers, 1, 2, 3 and 4, and the possibility for Matt's numbers, which again is 1, 2, 3 and 4, we can work out what these are being multiplied by each other. Now the product is a fancied name for multiply. So first of all, 1 multiplied by 1 is 1, 1 times 2 is 2, and so on. So we can always just use the calculator for this if you'd need. But multiplying each number above by each number to the side we'd get these totals here. And so the probability that the number chosen is a two-digit number, we can see how many possible outcomes there are. There's 16 possible combinations, and of these combinations, 3 of which is a two-digit number: 12, 12, and 16. And so there's 3 different possible ways a two-digit number could be made. And so this one here would be 3 out of a total of 16 possible outcomes. So the probability of ending up with a two-digit number is 3 over 16. Question 24. The area of an ellipse, width A and height B, is given by a formula here. The area of it is pi AB divided by 4. And so a rectangular photograph measures 15 by 10 and it's put into a frame shown. The part of the photograph that can be seen is an ellipse. So this bit here that can be seen is an ellipse. We have a formula for that as well. And the formula for the area of the ellipse is given here, pi AB divided by 4. And so in this case, A is the length of the ellipse, which in this particular case is 15, and B is the height or the width of the ellipse, which in our case of this picture frame is 10. And so the area of this ellipse we can work out now. So the area of it is pi multiplied by a, which is 15, multiplied by b, which is 10, and all of that divided by 4. And so we can type this into our calculator easily enough. You can use a pi button as well, which in this particular calculator is down here. So shift pi multiplied by a, which is 15, multiplied by b, which is 10, equals, and all of that divided by 4, which comes to, in terms of pi, 75 over 2 pi, and as a actual whole, as a number answer, is 117.809, and so on. At this point, I would recommend not to round off your answer. Round off an answer towards the end of a calculation, but never round off too soon. So it's 8097245. Yeah, that's what we had. And so for the ellipse, the area is this 117.8097245. We want to work out though the percentage of the photograph that can be seen. And so it's a rectangular photograph. And so what we can do is work out the area of the rectangle, which is a much easier formula to do. The area of any rectangle is just the length times the width. So in this case it's just 15 multiplied by 10, which is 150 square centimetres. We want to work out the fraction of the photograph that can be seen, which is essentially the fraction of the entire rectangle, which is the elliptical part. What can be seen is this elliptical bit in the middle. What can't be seen is this bit of a rectangle around the 4 corners. And so the fraction that can be seen the fraction that's visible is the area of the middle ellipse as a fraction of the whole picture frame, and the whole picture frame is the entire rectangle, which is 150. So that's a fraction which is visible. Now, to change from a fraction to a percentage, we just need to multiply the fraction by 100, because percentage means out of 100. So as I say, don't round off too soon. We can round off at the end. So it's that fraction of 100 to change it to a percentage. Press equals, and we'd get 78.5% to 3 significant figures. So that comes to 78.5%, because the question asks us to give the answer as a percentage. And so to 1 decimal place, that'd be 78.5% is visible. Question 25, we have a simultaneous equation problem here, which is rather nasty. Now it can be solved by using trial and improvement as well, just by guessing different prices for the adult ticket and the child ticket until you arrive at 2 values at work. But I'm going to show you now how to do a method using simultaneous equations. And so, if we just call the adult tickets A and the child tickets C, A for adults, C for children obviously, we can generate 2 lots of equations here. And so, for the top one, 3 adult tickets plus 4 child tickets costs £23. And the bottom equation, 1 adult ticket plus 5 child tickets costs £15. And so, with simultaneous equations, what we need to do is have the number of one letter to be the same. Ignoring the signs for the time being, either we need the A's to be the same number of A's, or the C's to be the same number. Now, as it stands, the A's are different, and the C's are different. On the top we have 3A, at the bottom we only have 1A. And at the top we have 4c, at the bottom we have 5c, so we can't really do anything right now. But what we could do in the bottom equation is we could make this a into 3a by just multiplying this by 3. But if we do that, what we need to do to everything in this equation is multiply the entire thing by 3. And so if we do that, the top can stay as it is. We've got 3a plus 4c equals 23. And at the bottom, if we multiply a by 3, we'll have 3a. And multiply 5c by 3 will be 15c. And also multiply the final value by 3. 15 multiplied by 3 will be 45. So if we look here now, we got the same number of a's in the top and the bottom equation. So what we need to do is to eliminate the a's from both equations. Now we can do that by doing one equation subtracted by the other. Both of these a's, these three a's, are positive in both the top equation and the bottom. So if we were to do 3a take away 3a, we'd get no a's at all, which is what we want to do. We want to eliminate one unknown, so we can just focus on the other one. The only thing is, if we were to do the top equation to take away the bottom, sure, the a's would disappear, but with the c's, we'd have to do 4c take away 15c, which would give us a minus value. So before we continue, what we're allowed to do, and what I'd suggest we do, is to swap the order of the equations. And so what I'm going to do is write the bottom one on the top, and the one on the top, I'm going to put that on the bottom. Now what we can do is just do the top equation, take away the bottom one. So we're taking away all of the top, sorry, we're taking away all the bottom from the top. And so if we do this first of all for the a's, 3a take away 3a, we'd have nothing at all, which is exactly what we want to happen. Next, looking at the c's, 5c take away, sorry, 15c take away 4c would leave us with 11c. And finally the values, 45 minus 23 would give us 22. Now from here, we can work out the cost of one child ticket by dividing both sides by 11. We don't want to know the cost of 11 child tickets, we want the cost of just one. And so if this 11 swaps sides, it swaps signs. So c is 22 divided by 11, which would be 2. Another way of looking at it would just be 11 multiplied by what number would give us 22? It's got to be 2. And so each child ticket is worth £2. Now that we know that, we can then substitute this value of c back into one of the initial equations. It doesn't matter which one you pick either, but what I'd suggest is to pick this equation here. Because now we want to work out the cost of an adult ticket, and this equation only has one adult ticket in it, so there's no need to do as much work as we would if we picked the top equation. And so just writing down this equation again, a plus 5c equals £15. But we've now worked out what c is. We now know that c is 2. And so because of that, we can substitute in the value for c in place of the letter. And so leave a as it is, because that's what we're trying to work out. 5c, because c is 2, means 5 multiplied by 2, which is 10. Because c is 2, 5 times 2 is 10, and that equals 15. So then if we rearrange this equation, move that plus 10 to the other side, so we have a on its own. If we swap side, we swap sign, then a would be 15 minus 10, which should be 5. Therefore, the cost of a child ticket is £2, and the cost of an adult ticket is £5. That's a very tough question for foundation. Simultaneous equations are one of the hardest things you may come across. And finally, we're now on question 26, the very last question of the paper, so well done for getting this far. So we have a doctor's claim that the probability of having regular illness is doubled if you have poor sleep rather than good sleep. I'm just going to highlight his claim in yellow. Because we need to comment on the doctor's claim. And in a survey, 16% of people with poor sleep had regular illness. So we can just make a note of this at the top. So those with poor sleep (16%) had regular illness. So now what we can do is compare that with those that have good sleep. So if we have a look here, for the good sleepers, lucky them, we can look at the total of them. So for those with good sleep, how many people have been recorded in total? 24 people with regular illness plus 276 with not regular illness. That gives us a total of 224 plus 276, which we can work out on a calculator if we'd like to. And we may as well, since it's a calculator paper. But that will give us a total of 300 people. And of those 300 people that had good sleep, we can see from the data in the table that 24 people out of those 300 had regular illness. So if 24 out of 300 had regular illness, we can easily enough write this as a fraction. 24 out of 300 would be 24 over 300. And to change from a fraction to a percentage, we simply just multiply by 100. And so trying this on our calculator, 24 over 300 multiplied by 100 would give us 8%. So 8% of good sleepers have regular illness. So now we've got two figures to compare. So good sleepers, 8% have regular illness. Poor sleepers, 16% have regular illness. Let's go back to the initial doctor's claim that the probability of having regular illness is doubled if you have poor sleep rather than good sleep. And so the probability of having regular illness if you have good sleep is 8%. If we double 8%, 8 multiplied 2, then yes, we do get 16%. And so the probability of having regular illness with poor sleep is double that than if you had good sleep, because 8 multiplied by 2 does give us 16. Therefore, we can conclude by saying, yes, the doctor is correct. Doctor is correct, because basically 16% is double 8%. And that will do to get the marks for question 26. So that's it for question 26 and for the whole paper as well. Once again, I hope you found at least some of that useful and not too dull or boring. So keep revising, keep working on those practice papers, and keep working particularly on your weaker areas. That way you'll maximise your chances of getting what you need for these exams. So once again, the very best of luck. Thanks for visiting, and I'll see you again soon.